So, just so y'all know, usually on a Thursday, because of course we have our quiz, usually I'll start with a warm-up. I'm not going to do that today because your quiz isn't really an official quiz, it's a diagnostic. So your diagnostic quiz is going to cover a little bit of pre-calculus material that you kind of need to know to do some of this stuff later on. Not really this truth table stuff. But if you go through the quiz today and you feel a little rusty, I'll try to compile a couple things to post on Blackboard. To give you an idea of places you could go to brush up on those kind of things, because unfortunately we don't have the time to review those very much. But it's a lot of, just factoring and doing a little bit of solving some systems of equations we'll need to do in one topic that we talk about. So if you really take the quiz today and you're really feeling rusty, keep an eye out for some pre-calculus stuff I'll put on Blackboard. Anyway, so the other day we started talking about truth tables. And we're going to keep talking about truth tables. So remember, truth tables are essentially we're taking these statements and now we're starting to form more complicated statements together, and we're able to kind of tell whether the more complicated statement is true or false based off kind of the pieces. And we talked about kind of these generic pieces here: the and, the or, exclusive or, implies, and if and only if. The main ones we're really going to be using, because we break it down so well, is we're going to mainly be using the not, and, or, and implies. So the if and only if and the exclusive are aren't used as often. And if we usually have an if and only if, we kind of break it up in terms of it implies in one direction and implies in the other direction, and then an and. Anyway, so let's see what one of those slightly more complicated truth tables would look like, which is down here. I do want to say another way that these types of questions can be phrased. So right now it just says obviously complete the truth table. More often these will be phrased in some kind of way. Oh, my laptop is angry. One moment.
Erin, I have a question.
Yeah.
You said that we'll have a quiz today. Is this correct?
Yes, but
Okay.
don't panic.
When is it? When do we need to complete it by?
So this one doesn't have a time constraint on it. I'll probably start putting them on. If you have, so I've already talked to a couple people who have like a class directly after this. So if you have something that you think you might not be able to complete them in time, let me know. The large majority of the time, my quizzes only take about 10-15 minutes. I usually don't have any problem with people completing before the end of the class time. But if that seems to be a problem, just, let me know and we'll work something out.
Do we access it on Blackboard, or is it like going to be from like your screen?
Oh, it'll be through Blackboard. You won't see it there now. It only appears when I want it to. But it'll be on Blackboard in the assignment tab towards the very end of class.
Awesome. Thank you.
Seems like my laptop is happy again. What was I saying? Different ways this will be phrased. So this will sometimes be phrased as complete the truth table for, and then it'll actually give you the thing it actually wants you to work up to. So a lot of times you'll actually be asked to complete the truth table for this nasty thing, and then you kind of have to complete the table in its pieces. So we always do break this up into as many pieces as possible, kind of. So it's kind of made up of, this and statement, there's a not statement, and then of course the implies that links the two together. So essentially when you're doing these, you break it down to its pieces, so we'll figure out the things around the implies first, and then do the implication. So I filled out the first little part. Remember, the reason we have 4 of those is we need to not compare. We need to consider absolutely every way these could be paired up. So true, 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 false, false, true, false, false. So let's take this one. I think I called that an and that's an or. I'm sorry, my brain's a little scattered. So that's an or. Sorry if I called that an and, I can't remember. Anyway, so our first column we're looking at is this or. So remember, that's one or the other, or both. If it's not an exclusive or, we could have both. So if both are true, the or would be true. If we have a true and then a false, one of them is true, so the entire thing is true. False, true is essentially the same. One of them is true, so the entire thing is true. And then false, false, since they're both false, that would give us false. And now the next column is not P. So this is the one thing about truth tables that can get, I don't even want to say it's tricky, but it's just you need to be careful because now we need to say, okay, well, not P is looking at this column over here. So make sure we're always looking at the right column. So remember, not P is essentially just the opposite of whatever P is. So if P is true, not P is false. If P is true, not P is false. And if P is true, not P is, no, sorry, goodness gracious. If P is false, not P is true, and not P is true. I changed to black, apparently. And then for the last piece, we essentially now want to group them together. So this is actually quite a small truth table. I'm not going to give you anything too large, but this would be considered a small truth table. Sometimes you'll have, you know, a decent amount of columns, and the last step you have like a column back in the third, and then the last column. So I like to kind of keep track of what we're working with. So we're essentially taking this column and implying it nicely to the one directly next to it. Sometimes they'll end up not directly next to each other. But remember, implies is the one that gets a little weird. So true implies false is the only case when an implication was false. So that gives us a false implication. True implies false would therefore also be false because it's the same thing. True implies true. If you have a true statement implying a true statement, that is true. And remember, with implication, the false ones are weird, where you have a false implying anything. If you have a false implying anything, that would be a true for the implication. And just, I don't like how that's a different color. False, false. True, true. All right. Questions, concerns on that? All right, now I'm going to say this, and it's always this super awkwardness when I'm teaching online. I want y'all to try the next one. So I'm going to sit in awkward silence for like a minute, a minute and a half, maybe 2 minutes, and then we'll go over it. But I want you to try to fill that out first. All right, probably don't need too much time for that one. So let's go over this one. And someone told me they're done. Yay! So not Q. Be careful. Make sure you're looking at the Q column, not P. So you're going to essentially just do the opposite of whatever the original Q was. If Q was true, it's false. If it was false, it's true. And then we want to and them together. So this is what I kind of meant, where they kind of don't end up necessarily next to each other. So we want to take those two. So sometimes if I'm doing these on paper, I'll like awkwardly space my fingers out from each other and kind of go down that way to kind of keep track. So we have P and not Q. So true and false would be false. Whoops. So remember, with an and, they both have to be true for the and to be false. Sorry, they both have to be true for the and to be true. True and true would give true. False and false, false, false and true. False. I'm real sorry. My brain's all over the place. All right. So.
Hey, Aaron, sorry, quick question.
What up?
This is Vince. The one the third one down, wouldn't that, or sorry, the last one, if it's false and false, wouldn't that imply a true, or am I misunderstanding that?
So a lot of people get that mixed up. So what we're trying to actually think of is the truth of this statement. So it's not that they have to just agree with each other. So I know when I say and, it might make you think they're the same. But if you think of like P being a statement, I buy bread, and Q being a statement, I buy milk. If I go up to my mother and say, I bought milk and bread, but I don't have either of them, then I lied. So essentially, if both of them are false, if I link them together with an and, it would still be a false statement. Does that make sense?
Yeah.
Yeah, so the only time that an and is true is when they're both true. So the false would be a false. All right. So any more questions before we move on a little bit? All right. Cool. Two statements are called logically equivalent. If they have the same true false values for all cases. So essentially, if we were to do the truth table for both of these, and we laid the truth table out in the same fashion, would their end result have the same exact, true or false cases? So given a statement P implies Q, the P implies Q would just be like the original. There's not really a name for that. So say, let me make the example, if the ground is wet, then it is raining. I'm not saying whether or not these statements are true or false. I'm just trying to write a statement down. So essentially, P is the ground is wet, and Q is when it's raining. Then it is raining. Sorry, it is raining. Goodness gracious. So P, ground is wet, Q, it is raining. We have these two kind of special, special setups, I guess. So if we essentially flip them around and negate both of them, so we turn it into not Q implies not P, this is called the contrapositive. And this is going to come back up next chapter as well. So essentially, we're going to switch it around and make both of them essentially a not. So what this would say is it would say if the ground is not wet, then it is not raining. And again, not saying anything about the true or false values of these yet, just writing down what they are. And then somewhat similarly, but without the negation, we just flip-flop it around. This is going to be called the converse. So the converse of the original statement would be if it is raining, then the ground is wet. Did I mess it up? Yep. I didn't switch it around, did I? So sorry. Sorry about that. I negated them, but I didn't switch it around. So let me do that in red so you know that that's the part I screwed up. So if it is not raining. Thank you very much. Then the ground is not wet. Sorry about that. So yeah, sorry, the contrapositive, you not only have to switch them around, which I didn't do, you've also have to negate them. Give you a couple seconds to finish writing that down. So again, I haven't really said anything I just defined logically equivalent. I haven't said whether or not these are equivalent or not. So let's take a look at the truth tables of these things. So if we want to take the truth table of the contrapositive first, so let's first find, just for giggles, let's find what the original would be. So if we have true implies true, true, true implies false is the only case where an implication turns out to be false. And then false implies anything ends up being true. Because remember, that's the case where it's kind of like, think of it as a promise. If I tell you if it's raining, I'll drive you home, but it's not raining, then you can't really say that I lied to you, whether or not I drove you home. And then if we need to negate both of them separately, so not P would be the opposite of whatever's in the P column. So false, false, true, true. Negate the Q, false, true, false, true. And this is one of those things where I start going too fast and you don't remember how they go from the other day, just stop me. And now we need to do, ooh, I don't like how I set it up, but it's unfortunate. So we have to go not Q implies not P. So be very careful about the direction. We're essentially going from the right to left here when we're looking at these columns. So we have false implies false would be true. True implies false would be false. False implies true, true, true implies true, true. So now if I clean this back up a little bit. So now the point is that look at the original implication, truth column, and then look at the contrapositive. They're the exact same ones in each one. It's true, false, true, true. So it turns out to be that the contrapositive is logically equivalent to the original. Oh, yeah, I'll talk about that. How does the false imply a true be? How does, okay, yeah, false imply true, question mark. So let's go with the, if it is raining, then I will drive you home. So let's take an example of the statement is, if it is raining, then I will drive you home. Okay, say I say that to you. Say it's not raining, but I still drive you home. That doesn't mean that when I told you, hey, if it's raining, I'll drive you home was a lie. So it's almost like because the first thing didn't even happen, it's kind of treated as like vacuously true in a way. Whereas maybe if it was raining, I would have driven you home, and then that would have been true implies true, which is the reason why the only thing that's false for an implication is false implies true. So essentially, sorry, I said that backwards, gosh. The only thing that's false for an implication is a true implies false. If it's raining and I don't drive you home, then I lied. But with the false implies anything, it's essentially if it's not raining, I didn't necessarily lie to you. We can't really tell if I lied to you or not because we don't know because it's not raining. So that's why false implies true is still treated as true. Because it doesn't even matter whether the back thing is true or false. The first thing is false. It's kind of vacuously true in a way. Does that make sense? I know it's like weird to think about. The false implies anything is like the hardest one to get your mind around. But that's kind of why it's treated as true. Because just because I drove you home doesn't mean I lied saying if it was raining, I would drive you home.
Professor, can you do me a small favor? Can you reiterate the first column of that worksheet?
This
like
one?
The first, yeah.
Sure.
Oh, I'm sorry. The straight across. Straight across.
This one? Or, sorry. This table, table number 1, or table number 2?
Table number 2, directly across where you circled.
Directly across. So what I have circled there, I'm sorry, my brain's not working today.
Yeah, that one.
Okay. So we have true and true. So for the first piece, we wanted to take a true implies true. The true implies a true gave me the true here. And then because, if I say, if it's raining, I drive you home, and it's raining and I drove you home, then I told the truth. For the not cases, we want to negate both of the original pieces. So since P was originally true, the negation becomes false. And then since Q is originally true, the negation becomes false. And then for the contrapositive negation, nope, that's the contrapositive. For the contrapositive case, we essentially, now remember, we're going Q implies P. The not Q implies not P. I should be very careful with my phrasing here. So we have a false implies false. And again, with the implication, if it starts with a false, no matter what it ends with, it's going to be a true implication. Because again, if I tell you, if it's raining, I'll drive you home, but it's not raining and I didn't drive you home, I didn't necessarily lie to you. So even a false implies false is a true statement in the implication. Did that help?
Yes, thank you. I'm majorly brain farted.
No, it's okay. It's a brain fart kind of day. So, all right. Any more questions on that one before we do the converse truth table? Yeah, okay, cool. All right. So the converse is not quite as long of a truth table, and the one we kind of already have filled out. So the implication is, we've already kind of talked about that. If you want me to talk about it again, just tell me to talk about it again. But true, false, true, true. And then we want to essentially go the opposite direction. So we need to be kind of careful. We need to go Q implies P. So the first row would give us a true implies true, which would result in a true statement. A false implies true. If it starts with a false in an implication, it's kind of vacuously true. True implies false is the only case where that implication is going to be false. False implies false is just kind of vacuously true. Vacuously is probably not the correct word, but hopefully y'all know what I mean when I say that. So notice that these do not match up. So there's essentially those two middle rows do not agree with each other. So the converse is not logically equivalent. To the original. So essentially what we're eventually going to do with these things, it's not going to come up, it's going to kind of go away for a little bit and then come back later. But essentially what we're going to do is we're going to eventually get to things where we want to prove that something is true. And it's easier to prove, not in a truth table sense, I should also clarify. And it's going to be easier to prove that the contrapositive is true than it is to prove that the original is true. But since they're logically equivalent, if you prove one, then the other one must also be true. So essentially that's what we're going to use this kind of logical equivalence for, is if it's easier to prove a logically equivalent statement, then we'll prove that one and then just kind of automatically get the other one. I think this is saying exactly what I kind of wrote down for statement S. Now this statement S, this can be anything. Like what we were focusing on in the top ones is we were focusing on P implies Q. That P and that Q could be more complicated. It could be some P or Q implies R or something like that. So S, saying a statement S is just a way to say it's absolutely any statement you can think of which has an implication in it. So for a statement S, the contrapositive is logically equivalent. But the converse is not. So kind of already said that, but. So say we want to consider the following. So we have P is the statement you earned 90 points on an exam, Q is the statement you earned an A on the exam, and R is the statement you failed an exam. So first thing we want to do is find the converse to P implies Q. Well, the converse in symbols would be Q implies P. So the converse, remember, you just flip it. It's the contrapositive that we do the extra bits to. So now let's go ahead and write it out in terms of the English statements that we have. So Q, you earned an A on an exam. So remember, an implication is usually written as an if-then. If you want to put the if in the middle and make sure to, kind of flip-flop them around, that's fine. But I'll usually just use the if-then. So if you earn an A on an exam, then you earned 90 points on an exam. Now, just to super duper clarify, when we're just writing these statements out, we're not saying anything about whether they're true or false. Like, obviously, if you just think about life, you could get an A on an exam and not have 90 points. So when we write these statements out in English, we're not saying they're true or a false statement necessarily. We haven't looked into that yet. And then I'll wait a couple seconds so you can write that down. Find the contrapositive to R, Q implies not R. Now, this one gets a tiny bit more complicated because it's just not, Q implies R. It's got that not there. So I'm going to be very, very general here for a second. So we flip them around and we negate both of them. Now, if you negate something that was already a not, it just becomes a regular old quote unquote positive one. It's not really negation, and a negative times a negative is a positive necessarily. But if you say not, a double negative, even in English, is a positive. If you really wanted to write not when you wrote that out, you could. But I would just change it over to the positive. So now if we want to write this down, we'll say if, it's an implication, if you failed an exam. Then, so not Q, you did not earn an A. On an exam. Maybe I'll even say, well, no, and the other one said and. So. Questions, concerns on that? All right. Wait a couple seconds before I scroll down. Wouldn't it be the other way around? Did I do something stupid again? So it's specifically because we're asked to find the contrapositive of this. So the original thing we're given is Q implies not R. But since we want to find the contrapositive, and the contrapositive takes the original and flips the things around and negates them both, that's why it suddenly becomes the R in the front instead of the Q. If I was writing the original statement, no, you're fine. The original statement, the Q came first. Contrapositive, flip it over. All right. Consider the following truth tables, and it is 12. Okay. Consider the following truth tables to determine if the two end results are equivalent. Now, also, this is where I wanted to, excuse me, bring back in that idea that I told you about on Tuesday, is that some of these truth tables can be used as zeros and ones. So I also wanted to bring that back in. So we're also going to be comparing T's and F's to zeros and ones. Woohoo! Here we go. All right. So we got to fill these out. So implication, true implies true is true. False, true, true. When we're starting to do these, I'm going to go through the ones that we've kind of done a bunch of times quickly. Please, if you need clarification again, I know brains are weird. Just make me do it again. So then if we want to negate that entire implication, we would have false, true, false, false. Essentially just take everything that's here and switch it to the other option. And then here, so remember that a 0 will be essentially a false and a 1 will be a true. And if like on an exam or something, you like using zeros and ones instead of T's and F's, go right ahead. So if we want to negate P, we're essentially going to take the P column and just give the other option. So that false becomes a true. So the 0 becomes a 1, 1 becomes a 0, 0 becomes a 1, 1 becomes a 0. If we then need to consider not P or Q, so since it's an or, one or the other or both has to be true, or in this case, a 1. So since we have a true and a true, a 1 and a 1, that would be true. The 0, 0, oh, now I've changed back to trues, would be a 1. 0, 0, since those both represent false, would be false, so 0. 0, 1, one of them is the true option, so the or would be true, so 1. 1 and 0, one of them is true, so the or statement is true. And then we want to negate what we just found. So 0, 1, 0, 0. So if we wanted to figure out whether these two things were logically equivalent, we need to look at this column compared to this column. And let's change one of them over to the other form just to really hit it home. So that 0 is representing a false, 1 representing a true, and then false, false. The first truth table is false, true, false, false. I don't have a not Q. So, oh, I also did a fancy thing here as well. Ooh, wait, no, I was trickier than I thought I was. Ooh, I'm a little tricky trickster. Ooh, I'm a tricky trickster. Okay. So, to answer your question, Linda, are you talking about this one right here? No, you're fine. So actually, I was about to do this question wrong because I can't read my own question here. So you want to be very, very careful. And actually, this is why I did the question like this, because I wanted to point it out. Note that if you were just going off of this last row, last column, it's a column. This last column, it would look like false, true, false, false, and it would look like they match, right? But what past me did really, really tricky trickster is notice that they actually set up the original P and Q differently. So if I change these to trues and false, I'd have false, true, false, true, true, false, false, true, which is not the correct setup here. So actually, if we would want to consider whether these two are logically equivalent, and this happens a lot because not everyone sets up their truth tables the same. I personally always go true, true, false, false, true, false, true, false. Some people go false, false, true, true, you know, and whatever floats their boat. So you do want to be very careful when you're comparing completely different truth tables. So I have a true and a true. I'm going to call that option 1. So the true, true in the second one is actually way down here. So we'd be comparing a false to a false. That one matches up. Awesome. Cool. Different color. Now let's look at the true. Yeah. So let's look at the true false row. So the true false row in the second one turned out to be that second row still. So we're comparing a true to a true. So that's still good. So it actually looks like it's still going to be logically equivalent, but we need to talk about it. And then if we look at the third row, we've got a false true, which turned out to be the first row in our second one. So we're comparing a false to a false. So that's good. I don't know why I circled the one in the one column and the other one in the other one. And then for the last one, our false implies false was actually the third row in the other one. So we're comparing a false to a false. Let me move that other that other thing over here. So actually, this still does turn out to be logically equivalent. Let me like write that over here. But you do need to be very careful if you're given like two separate truth tables to also not necessarily look at the final column, but to also make sure that the rows were set up in the right way, or not even the right way, in the same way. Because if the rows weren't set up in the same way, then it takes a little bit more time to figure out which one's which. Yeah, in the second one. So for that one, we're essentially negating the or statement that we had just found. So the or statement was back here, and then we essentially want to negate that column. So if the column started with a true, a 1, then it would become a false, a 0. And then we had a false, a 0, becoming a true or a 1. A true becoming a false, a true becoming a false. Makes sense? Okay. It's got a whole lot going on, especially because I was about to mess it up. There's a lot going on here, but again, to just break down what we did both truth tables. Yes, I pulled out the 0, 1 notation to throw you off a little bit. And then we wanted to compare the two. But once we realized that the rows are not set up in the same way, we need to be a bit more careful. But it actually did turn out that this still is logically equivalent because all the rows turned out to have the same final true or false value. Any more questions about that? Oh, Savannah, I didn't even see your question. Last row. Oh, okay, good. Because I don't even know if I understand your question, but I'm glad it got answered anyway. All right, any more questions on that? Sorry, it was a lot, and I threw in some curveballs in there. All right. We might not be able to do both of these, but I at least want to get into one because these ones get a little long. So, but here we go. So essentially what we're going to do now is we have some statements here and we're going to create a truth table. It's going to be one of our biggest truth tables we've done so far to essentially answer the question. So essentially we have if Aaron is late, then Bill is late. And if both Aaron and Bill are late, then class is boring. Suppose that class is not boring. What can you conclude about Aaron and Bill? So I got to make sure I don't run out of space. So let me go all the way over here to define some things. So I'm going to use A for Aaron is late. Doesn't matter what letter you use. I just like choosing ones that somewhat reflect the question. I'm going to use B for Bill is late. I'm going to use C for class is boring. Yeah, you're about to see where this is going to be a 8-row truth table instead of a 6, and it can get a little hard to keep track of what row goes to where. I probably should have put in a blank table in here, but I wasn't nice. So essentially when we're viewing a question like this, essentially everything we're told, we're assuming is true. So notice that the first thing we're told is that Aaron is late. If Aaron is late, then Bill is late. That would give me A implies B. If Aaron is late, then Bill is late. Now, the one thing about this is the and you don't really have to worry about. You can just break it down into separate pieces. So I'm going to take this as one statement being Aaron is late, Bill is late, and then a completely separate statement to be if both Aaron and Bill are late, then class is boring. The reason I don't need to worry about that and is essentially the way we're going to then deal with the truth table. So I'll try to come back to that in a second. So this other statement that I'm finding is if both Bill and Aaron are late. I know I said that backwards. So essentially, if Aaron and Bill are both late, then class is boring. Now you also want to be very careful. Notice that the Aaron and Bill are late comes before the then. And since it's kind of a more complex thing than just one variable, I should put it in parentheses. Okay. So if essentially you have an if-then statement and there's more than just one term, if you will, between the if and then, put it in parentheses. And then the next sentence says, suppose that class is not boring. So if class is not boring, the thing we would know is true is that not C would end up being true. And you'll see what I mean by end up being true in a second. But that's essentially what that statement is giving me. Class is not boring, which would give me not C. So those are the three things I'm going to focus on once we finish doing this rather large table. So now we got to start on a very large table. So we have A, B, and C. So the fact that we now have 3 variables instead of 2 is what gets us the extra rows. And once again, we have to consider essentially every pairing of true false. So what I like to do is I like to start the very first one by just going half true, half false. Like the first half are true, the first half are false. So I would go 4 true and then 4 false. And I'm going to try to space them out a little bit to make sure I try to keep the things that need to be next to each other. And then with an 8 row, the second column I like to do in batches of 2. So I would do something like true, true, false, false, true, true, false, false. Again, it doesn't really matter how you set it up as long as you consider each and every possibility. But if you don't have some kind of normal way that you do it, you'll probably end up like accidentally missing some things. And then the very last column is always just back and forth. So true, false, true, false, true, false, true, false. Got a lot of rows. We will not get to the second one today. That's okay. So the next thing I'll do, so we essentially need to eventually have all of these 3 things separately on the truth table. So I'm going to go ahead and do not C first because that one's like one of the easier ones. So I'm going to do not C first. So essentially I forget about everything but the column C, and I'm just going to essentially flip-flop all of the values. So it'll be false. Why is it writing over there? False, true, false, true, false, true, false, true. And hold on a second, because y'all might need to catch up. I gotta remember. So we've taken care of not C. I can do these in any order I want. I'm personally going to do the implication next because that's the next one that takes the next least amount of work. So we want to be careful. We're looking at these 2 columns back here. So we have true implies true twice. So that'll give us true, true. So essentially, since the B came in batches of 2, this is also kind of going to come in batches of 2. And then we have 2 sets of true implies false. Remember, true implies false is the only case when an implication is false. We have 2 batches of false implies true. And then 2 batches of false implies false. And when we start with a false for an implication, it always ends up true. And then for the last thing I need to build up to, this A and B implies C, I need to break it up into A and B first. So the first thing I would need to find is A and B. So I shouldn't have erased that because we're still looking at these 2 columns back here. And again, they're kind of coming in batches of 2 because we're not taking into consideration the C yet. So we have true, true. And the and situation would give us a true, because remember, for the and to be true, both of the pieces have to be true. So true, true. True, false. Since one of them is false, that would mean the and is false. False. false, true. One of them is false, so the entire and statement is false. False, false. Both are false. Remember, we want the and statement to be true, so if both your pieces are false, there's no way them together can be true. So false and false is false. We're almost done. One more, and then we can look into actually how we're going to solve the question. So now that we have that, we can imply it to C. So we're essentially taking this, and I'll breathe for a second before I go through, but let me just draw my little there. So we need to take the column we just did and imply it back to C. So be careful, we're kind of working right to left here. So we have a true implies true, gives us a true statement. True implies false, only thing that gives us a false. False implies true, true. False implies false, true. You guys remember anything that starts with it? So essentially all the rest of them are going to turn out true because they start with a false. False implies true, true. False implies false, true. False implies true, true. False implies false, true.
So just so that I have it absolutely clear,
Mm-hmm.
in an and only thing that we're talking about, a false and a false yields a false. But if it's an and that goes to an implies, a false and false implies a true.
So yes, and I want to just be clear that the difference is that the actual thing we're considering in just the and is the main thing we're considering is the and. Essentially in this one here, it's almost like we don't care about the and statement anymore. It's like its own new thing and we're just implying. So that's kind of the difference.
Okay, so that's more like, that would be like a function result. Okay.
Yeah. So sometimes when I would be doing these way back when I learned this, I would sometimes be a little silly and I would just name this like star or smiley face, and then I would just say star implies C because I was too lazy to write out the and statement. But if that also helps you avoid confusion about anything, go ahead. Anyway, so we're at the point where we can actually answer this question. And here's why. Remember way back when at the very beginning I said everything that it gives us as a statement, we are assuming is true. So essentially that means is that we want to find where all three of these are true. So let's start with the implies. So go to the implies column, and we've got a true there, and then the last four are true. So when I did these notes by hand, I just kind of like boxed the result if you don't have a highlighter. So I just kind of boxed all the trues. And then we want to look at that A and B implies C. So let's, kind of note all of the, there's lots of trues there. Or you could just try to take the time to just find where they're all true and just box those. But I feel like taking them separately is a bit easier. And then we need the not C to be a true. And then the point is that you need all three of them to be true. Now there's two cases where that happens, which is fine. We have one case in this row and one case in this row. All of the other rows only have two or only one of the things being true. So now we answer our question. So we go back and let me remind us what the question actually asks. What can we conclude about Aaron and Bill? So essentially in the one situation, we have Aaron is not late, but Bill is. And then in the second situation, Aaron is still not late, but Bill is also not late. So you could write those as two different situations, but I would just kind of bring them together a little bit, and I'll say something like Aaron is not late, because in both situations he's not late. But we do not know about Bill. You could say Bill could be either late or not late or something like that. But essentially something to say, we're not exactly sure which one of those two we're in, but we know for sure that Aaron's not. Questions, concerns? I know that we were doing these seemingly small truth tables and all of a sudden I've blown things up for everything. So any questions or concerns about how I did that? We will obviously not get to this one because it'll take just about as long. So we'll start that one next week. On how I concluded that? Sure. So, okay, two questions. Answering Jessica's question will help with answering Brad's. So Jess, we know the class is not boring because if you notice, the not boring is true, or you could just think about it as the boring one is false. And that's actually because we're told that the class, oh no, that the class is not boring. So how we concluded this is that when you read this original statement, you know, we've done the truth table, let's go back to actually reading the problem. And the problem says, if Aaron is late, then Bill is late. And if both Aaron and Bill are late, then the class is boring. Suppose that the class is not boring. When you're given a question like this, every statement they say to you, you must assume is true. So we have, if Aaron is late, then Bill is late. So we must assume that A implies B is true. We have, if both Aaron and Bill are late, then class is boring. So we must assume that A and B implies C would be true. And we're also told to suppose that class is not boring. So we have to assume that not C is true. So essentially, once we've created this giant truth table, those three statements must be true. So what I did is I went and highlighted all of the places where those statements were true. I found all the places where not C was true, where the A implies B was true, and where the A and B implies C was true. And then the way you actually find the answer is when they are all actually true. So since there were only the two cases where all three of those statements were true, those two are our answers. So notice we have a couple of these other ones where we have like two of them highlighted, but the implication was not true. But we're told that if Aaron is late, then Bill is late. We must assume that's true. In that row, it's false, so that can't be our answer. So that's how you conclude the answer there. Hopefully that made sense. Any more questions? Okay, so again, we'll finish this last one on Tuesday, and then we'll start 1.2. 1.2 is essentially going to be how to start proving things without having to do very long truth tables. Because obviously, if you were to add in a fourth variable here, then we'd have 16 rows. And nobody wants to do a truth table with 16 rows. And people usually don't even want to do the ones with 8 rows. So we eventually need something that goes away from truth tables. So that'll kind of be what we lead into next. But anyway, so let me, I don't think it's quite appeared yet. So let me force your quiz to appear. Remember, don't panic about it. It's just a diagnostic. If you don't know how to do the things, you should just look for the pre-calc practice that I'll try to put up in the next couple of days. And yeah, so it is live. You can see it now. It's on Blackboard. So Blackboard, where's the, there we go. Sorry. It's on Blackboard under the assignment tab. A quiz on average is usually about 15 to 20 minutes. I'll probably put a time limit on them of like 25 to 30 minutes to give you a little bit extra time, but I just don't want them to be something that someone sits around for an hour and does, because that kind of deal. But this one's just open. But I would suggest maybe sticking around in case you have a question for the Teams call. But once you're done, you're free to leave. If you really want to leave now, that's perfectly fine. Do whatever floats your boat. But if you want to stick around in case you have a question you want to type out in chat, feel free to do that. But once you're done your quiz, you're free to go. Have a great day. Have a great weekend. I'll see you on Tuesday. Oh, sorry, Daily. Usually they close soon after class because really I would like you to be doing them towards the end of class. Again, if there's some reason that you won't be able to take it towards the end of class and be able to finish it, I will say that there's usually no problem finishing it. This one might be a tiny bit long, but again, it's a pre-diagnostic. There's usually no problem finishing it before class ends, but if you think you'll have issues, just shoot me an email.
Hey, Aaron, how exactly do I enter answers in here? I'm at question 1, and it asked me the question, and I've just got the button to save answer, but I've really got no field to type in my answer.
There's no text box?
The text
Oh, I
box
guess
appears
now
after a
it's here.
moment.
Okay.
Oh, yeah, that took a second. All right,
Okay.
never
Yeah.
mind.
Because I almost had the same question, and then it appeared for me.
Okay.
All right, never mind.